Hello everyone, welcome back to Malik 034 channel. This is Malik Arjun. So in this today's session, we are going to deep dive into a deep understanding of the cache fusion, how internally this cache fusion mechanism works, and how the data blocks are transferred between the cluster nodes, and how the dirty blocks or past images of a particular instance can be transferred to the other instance when there is a request, and via which network this data transfer happens, whether it's a private network or the cluster interconnects or the public network, on which network this data transfer happens. This everything we are gonna understand in deep details, and how the instance cache and then this global resource directory both are interlinked, and which are the background processes are responsible for managing this cache fusion. Everything we are gonna see it in details about complete cache fusion. So this is one of the common interview question in most of the DBA interviews. They will ask what is cache fusion, how the cache fusion will be handled in the multi-node RAC environment. So that we will shortly will understand in detail. So before I just start with this today's technical discussion, if you are new to my channel, always go back to YouTube and search for Malik 034, and then please do subscribe. If you like my videos, please don't forget to give a thumbs up and share with your friends and colleagues. And if you missed out my previous videos, you can always refer it in my channel Malik 034. Right, let's start with the cache fusion. So if you see this particular slide, I just given a simple definition of the cache fusion. In Oracle RAC, the data transfer from one buffer cache, one instance buffer cache to the other instance cache, other instance buffer cache of other instance across the cluster interconnects in the private network. It's called cache fusion. This is a simple word of definition. Basically, if you have a dirty buffers or a past image in instance 1, and if any connection from the instance 2 needs that block, directly that block can be transferred from instance 1 to instance 2. So without fetching the data from the data files or the physical data files, you can directly get that data from the other instance buffer cache. So that is kind of we can call it as a cache fusion. So what are the advantages of this cache fusion? There is no need of IO activity. If the buffer is if the block is already available in instance 1, so whatever the user connection to the instance 2 directly get the data block from the instance 1 directly. It no need to connect to data actual physical data files, and no need to fetch from the physical IO to the buffer cache and then represent it to the user. Rather than doing this IO directly from the buffer cache of instance 1, instance 2 will get the data and then it will be given to the end user. That is one of the advantages. And data block transfer via private network, that is a cluster interconnect network. So the private interconnect, everyone knows that it's a very much high speed data transfer. So the data movement or data transfer between the cluster nodes is very high, and very, that is a kind of a performance improvement, right, rather than IO activity. This is like kind of a improvement. It's kind of advantages of the cache fusion. So if you see this particular slide here, what I represented, I have SGA1 here and I have SGA2 here, means instance 1 and instance 2, and I have a data file here, like and inside that data file I have this block 1008. This is a data block, and that has been accessed by this SGA instance 1. And this is slide 1. In the single instance, the locking mechanism is easy and can be easily manageable. What that mean? The locking mechanism, locking manages two processes updating the same block at a time. Locking means if the two user processes are updating the same block, for example this 1008 is updating by one connection, and then the same block is updating by the other connection. One is trying to update it to 1009, and the other one is trying to update it to 1010 1010. So locking mechanism will help to hold one of the user session, and allow one user session to permit the operation. If both the user sessions are trying to update it, it is become inconsistent, right? So in single instance it's easy to manage, but whereas in RAC, you can see here 1008 is a block is already accessed by the instance 1. You can see here, right, it is already accessed by instance 1 here, and that instance 1, the one session has updated to 1009. And same time, if the other connection in instance 2, if update the same instance, if that reads 1008 and try to update it to 1010, then there is no there is no consistency in the data, because that block is already modified as a 1009. So whatever the connection in the instance 2 should get this 1009 instead of 1008, right? So that is kind of coherency, I can say, the consistency between the React nodes. In the React interconnects, the synchronization is a very important and one of the critical aspect to successfully run your React databases. So which will prevent the changing the same blocks by two different connections. What that mean by synchronization, you can see, right, this example only. Already instance 1 has modified this block and updated as a 1009, and if the other connection in instance 2 wants to modify that block, it has to get this 1009, and on top of that 1009 it has to do modification. If it gets this 1008 again and then try to modify that one, so that is kind of, there is no coherence and there is no synchronization between the cluster nodes. So in the internode synchronization guarantees that each instance sees the most recent version of the data block. So suppose this, the connection on the instance 2 should be able to see this block 1009 instead of 1008, so that the internode synchronization will be achieved and the coherency will be managed. That is one of the basic criteria for the rack cluster database to operate in the synchronization mode. And if I can go to the in deep dive how this can be achieved, then there are some background process comes into picture. One is GRD, that is a global resource directory, and the others are like global cache services, GCS, and global Enqueues services, that is GES. These are the three very important processes, I can say. One is the GRD table, and these two are the background processes. So what is a global resource coordination? How this coordination happens between the cluster nodes? You can see here this one node 1 and this is node n, and these all are the background processes. I'm not going to explain about the background processes, but I just wanted to tell you about these two background processes: global cache service and global enqueue services. These are the two no, my rack background services, and this is a table, global resource directory table, and each node has the GRD, the piece of information about this GRD table, that is GRD master. GRD master, you can see here, each, this is inside my SGA. If you can read this particular writings here, the cluster required synchronization among the cluster nodes. The cluster, if you are having a 2 node cluster or 3 node cluster, or whatever 4 node clusters, each cluster nodes requires the synchronization among the cluster nodes. I have 2 node racks and both the nodes should be synchronized each other. That's the first point. And the second point is the rack uses GRD, global resource directory, to record how the resources are used within the cluster. Like if I have 2 node cluster or 3 node cluster, this GRD table will be comes into picture. That plays very important aspects, that will manages and that will holds, and what are the my cluster resources and which are the cluster nodes holding which particular cluster resources. So all the information will be found from this GRD table. And then to help to manage this GRD table, we have two important background processes. One is GCS and one is GES. GCS is global cache service and GES is a global enqueue service. GCS and GES manages the information in the GRD, right? So GRD is a table which holds the information about the cluster resources, which resource is belongs to which node and which node has the latest data of particular block. Everything you can get it in this GRD table. So to manage that GRD table, this GES and GCS plays very important role, because those are the two background processes which will be helps managing your GRD table. And the fourth point is each instance manages a part of your GRD table in its SGA. If you can see, I have instance 1 here and I have instance n here, and instance 1 also have the piece of GRD table in its SGA, and instance n also has a piece of GRD table in its SGA. So that piece of information signifies whether which node has the master information. I will cover it in next slide. So let's go to the next slide. You can see the fifth point: GCS and GES nominates the master node to manage all the information in GRD. Suppose this is my GRD table, and either node 1 or node 2 will be nominated as the master node. Who will nominate the master node? My GCS and GES will nominate. Node 1 is going to be master node, and this node 1 is going to manage my GRD table. And suppose after some time GCS and GES together will nominate node 2 or node 3, or node 3 is going to be my master node, and then that particular node will manages my GRD table. Right, that is other point you should keep remember. And the sixth point is each instance knows who is the master in the cluster, and which instance has the what resource, which instance has the modified block, which instance has the latest block of my data. Each instance will communicate each other, and each instance will share the GRD information, and each instance know that which resource and which instance holds which data, and from where I can get the latest data. Everything can be intercommunicated. And the cache coherency is nothing but keeping data blocks consistent across the cluster nodes. Suppose if I have node 1 and node 2, and the node 1 holds the data with 1001, and node 2 holds the data 1003, and node 3 holds the data 1004. If the data block is inconsistent across the nodes, then there is no concept of cluster database here. So your cache coherency, that is a cluster node synchronization, is very important, because that is one of the key aspects of your cluster database. So keeping data blocks consistent across the cluster nodes is nothing but the cache coherency. So GCS implements this cache coherency by the technique called cache fusion algorithm. So I'll quickly explain cache fusion algorithm, how it works, in my next slide. So before that, this GCS is nothing but, I said, global Enqueue service. Global Enqueue service, GCS offers these three main functionalities. One is the dictionary cache locks, and library cache locks, and the deadlocks. These are the three lock mechanism GES will mainly performs. And go to the next slide. Global cache coordination. Global cache coordination, if you can see here, right, this numbering here, 1, 2, 3 and 4, what that number represents, you can see here, right, number 1, second instance tried to modify the block, and it submit the request to GCS. You can see, right, GCS is here. Global cache service is one of the background process, and one connection, I can say one user connection connected to node 2, and that node 2, that connection want to modify this particular block 1008, and then that request will go to my GCS. And then what GCS will do, GCS transmit that request to the node 1. Why it is sent to node 1? Because this 1008 is already modified by the node 1, and some connection has updated as a 1009. Already this block is modified, and it's already available in the instance 1, and it has committed, but it is not returned to the data file. Because the moment any request comes for that particular block, my GCS will send a request who is holding that particular block. It will send out, it will loudly speak out. My GCS will talk to all the instances who is holding this particular block, and then my GCS knows that instance 1 is holding this particular block, and then GCS transmit that request to the holder, that is node 1, that is instance 1. It will send that request to instance 1, and then my first instance receives that request from the GCS and sends that particular block to instance 2. You can see here 1009 that transferred to instance 2. You can see this step number 3 via private interconnect, that is a cluster interconnects, that is we can say HAIP, right, cluster interconnect. It will transfer via that private network, and it will send it to my instance 2 buffer cache. And the second instance informs to the GCS that I holds the block now, and it will update the GCS. second instance will talk to GCS. It will tell now I am holding that 1009 block and I have a latest data now. So if anybody asks, you can redirect the connection to me. I will send it to them. If I have a third instance and if the request comes for the same block, my GCS will send a request to the instance 2, so that the third node is asking for that block, and then instance 2 will send that block to the third instance. That's how it works in the global cache coordination with the help of GCS, right? And everything will be updated in my GRD, global resource directory. And if I go to the next slide and write to the disk coordination, and if I have these dirty blocks or the past images in my cache, database buffer cache, so how that can be written to the disk. And the same example, instance 1 has 1009 and instance 2 is modified as a 1010. You can see this like this numbering, right? 1 2 here and 3 here, 4 here, 5 here, right? See, first instance, what happened? First instance sends the write request to the GCS. So first instance is called of I can call it as a past image, because this 1008, earlier it was 1008, right? So if I can go back to the previous slide, 1008 was modified as a 1009 by instance 1, and the instance 2 now modified it as a 1010, and then that 1010 is the latest image now. So this image become a past image. Node 1, whatever the image, it become a past image now. You can see here, earlier it was 1008 and instance 1 modified as a 1009 but not returned to the disk, and again a request came to the node 2. Node 2 has updated it back to 1010, and now this 1010 is the latest image. So by some reason this instance 1 is buffer cache full, and some checkpoint happened, and this instance want to write this particular image to the disk, and the first instance sends the write request to GCS. Since it holds the dirty buffer, this is a dirty buffer not returned to the disk, and because of lack of buffer cache or some checkpoint or some crash happened, it sends the request to the GCS that I want to write this dirty buffer, this past image, to disk. That time GCS forwards that request to the instance 2. Why it sends that request to instance 2? Because the current image holder is instance 2. That instance 2 is marked as a in my GRD table, and this GCS is able to find out instance 2 is having the latest image copy of that block, and the commit request will send it to instance 2, and the second instance receives that request and writes the blocks to the disk. So the second instance will say that instead of 1009 I have a latest copy of that is 1010, let me write it to the disk. And then second instance confirms write operation to the GCS, and then 1010 will be returned to the disk, and then it will confirm back to the GCS that I have written the latest image of that block 1010 to the disk, and I take my my signature. It will send that confirmation back to the GCS, and GCS holders GCS sends GCS holder GCS sends to all the past image. I can say this is a past image, right? To the all the past image holders to discard their past images, because already latest block is updated in the disk to the data files. You can discard whatever your past images, and then instance 1 will discard that 1009, right? So that is how the disk write disk coordination happens with the help of GCS and GRD and Enqueues. And that's it about the cache fusion, how it works. So it looks like complication, the mechanism altogether looks like complicated, but RAC database is smart enough to manage it by own, so we no need to worry about that. But one of the common question, this every interview they will ask, what is cache fusion? In simple words, cache fusion is transferring your data blocks from one instance buffer cache to the other instance buffer cache. and in the private network or with the help of cluster interconnects, that is called a cache fusion. And what are the advantages? There is no need of IO activity, and data block transfer happens via private network, that is a cluster interconnect, that will be very high speed, and it's a performance improvement. These are like few of the advantages of cache fusion, and also helps in node internode synchronization, and cache coherency between the cluster nodes. And that's it about the today's session. I hope it is pretty informative, and I will definitely, there are few more topics like dynamic reconfiguration. As I said, like either of any one node is going to be master, and in case of that node goes down, and how the remastering happens, and if the master needs to transfer from one node to other node, how that remastering happens, and the internode row level locking, how it works, and parallel execution in the RAC, and in the RAC environment, how it works. And also there's a new concept, that is split brain syndrome. That is again the different concept, and that is one of the most common interview question: what is split brain syndrome, and how you can avoid that. So that is also one of the common question. I will explain it in my next session. Thank you guys.